On stage tonight, we have another design by the legendary Evan Perry, also known as Rhinestone Hurricane, right here on YouTube. Check him out. Today's design is made of wood and steel, and Evan calls it the organ donor. Why is that? Because it is actually made of antique organ parts donated by Musical Restorations. Now, I'm only guessing here, but I believe these are made from the stop knobs of a pipe organ. Now, I'm no expert on wood, but if I were to guess, this might be bird's eye maple. Yes, Evan is a man of mystery. Now, the organ donor has a long steel core that extends the entire length of the projectile. And you'll notice that it has sort of a Diablo shape, so it looks like Evan is hoping these will be self-stabilizing out of a smoothbore. Now, one concern I had was providing enough support of the core and the wooden body of this thing. So I added a stainless steel disc to the base of these things. And without support, that heavy core could actually be driven right through the wads and everything, and we could have a complete failure. This gives you an idea of where the center of gravity is. Weight is approximately 34 grams, 1.2 ounces, or 527 grains. Now, these are very long projectiles measuring just about 2 inches or around 50 millimeters in length. Now, this is a cutaway of the shell showing all the components used for today's test, including a 2-piece discarded sabot. Today we'll be using incremental powder loads starting with 25 grains, 27, and all the way up to 30 grains of long shot. And of course you would not want to load these into a tube magazine, otherwise you'd have a chain fire. There, I saved you from having to explain that to me. Now let's head out to the test range and see how the organ donors perform. Hey, we're back out here. Terrible overcast day, very dark. I can't imagine the high-speed camera footage looking very good today, but we're gonna try it anyway. I'm gonna run the camera really slow, slow frame rate, so that we can hopefully see how these perform. All I know is it's some kind of organ parts. I asked Evan to give me as much information about these as possible, and he said it came from some guy that works on organs or something. So anyway, we're going to start out with the 25 grainer and a smoothbore and see if these will self-stabilize. We're going to go straight to the lead plate right now, see if we can hit that. We're about 15 yards away. We're not super far away. Okay, shot number 1, 25 grains, aiming about 1 inch above the previous impact point there. Hopefully this will work. Smooth bore. So we had 1,096 feet per second with that lower power charge. Hopefully this will work. Smooth bore. Well, I took a chance and tried to film in these very dark conditions, and I was limited to running the camera at only 1,500 frames a second. On a sunny day, I'll run the camera at 5 or 10,000 frames a second. But we can see the Slug did pretty much a complete somersault and then shot a little bit low and struck the frame that holds the lead plate up. So it looks like we did not obtain stability out of a smoothbore. It appeared that it was flying very, very unstable. And it looks like we have a fresh little scar here. Shot a little bit low there's the back plate there. So let's give it another try with the rifled barrel and see if we have better results. Okay, another 25 grains. Okay, let's hit it. 1149. Well, I'm really hating the quality of this high-speed footage, but we can kind of see what happened there. It did not obtain stability, slapped that plate sideways. So let's look at the damage. Okay, definitely shot to the right, and looks like, I haven't looked at the high speed yet. I'm almost scared to, but that thing slapped the lead plate sideways. Lots of damage to the plate, but you know, we're wanting stability here, you know. So I'm gonna check out the high-speed footage on that. Hopefully I can see something, if we got the good spin or not. It's not looking good. Not looking good yet. Okay, the last of the 25 grain load, aiming just in the center of that steel plate. Let's see what she does.
Now this one is flying at a subsonic speed and spinning at around 20,000 RPM, but we did obtain stability. You have to squint a little bit there to see that, but it was flying nice, straight, and true. The accuracy was pretty good. Now this definitely gave me a little bit of hope for these projectiles after those first two failures. I was not sure what the others would look like. Now let's take a look at the damage.
Okay, I had to look at the high speed. It's hard to tell. Man, I wish it was a little brighter out today. I'm telling you, running at only 1,500 frames a second is not the way to go. But what else am I gonna do? It's been overcast like this for the last 2 weeks. Sun, I haven't seen the sun in a couple of weeks, but I believe it hit right here, right below that, if I'm not mistaken. Hardly a dent. Gives you a high idea how difficult that 3/8 mild steel plate is to penetrate, even with that nice sharp tip on that. So look at that spicy Bisquick still in there. The Trident still in there, permanently in there. So cool. So anyway, that one may have been flying stable. It's hard to tell. So let's see if we could increase the powder load to 27 now. Got a couple of those and then 3 30-grainers, I believe. So let's see if increasing the speed will help us in any way. Okay, an ice-filled jug. Someone suggests I put some dye in it in the last video. It's like, okay, we'll try that. So yeah, listen to your suggestions, you know, it's that easy, just suggest stuff. Now, I might do it. So anyway, we got a 27 grainer now. I don't know about these things. I have not been impressed yet, but there's still time for that. So let's see how 27 grains behaves. And here we go. And that was a miss.
The Slug is now traveling around 1,300 feet per second. It was tumbling around in it. But look at that, it looks like it's stabilized and then it starts tumbling again.
Okay, I promise you, it's the red dot's right on the center of that thing. Okay, here we go. Okay, we had some kind of impact that time. So that was 1255 on the lab radar. Okay, here we go.
Well, in this shot we got semi-stable flight on that one. Accuracy was terrible. That poor steel frame is sure taking a beating today. Ugh.
Okay, well, you can see I believe this is the new scar. Possibly hit there, but these things just are not working out. Definitely flew sideways. No stability, no accuracy. They're not stable. They're probably not going to be accurate. Okay, we got the wet catalogs. You're probably sick of seeing the ice jug not being hit, right? So we got a little bigger target. Might be able to have a better chance of hitting it. 3 U-line catalogs. They start out about this thick when they're dry and they swell up that much. So it's a good medium. It holds a lot of water. There's probably 1.5 gallons of water inside that, believe it or not. All right, next we've got 30 grain load. See if speeding it up even faster. We should be seeing close to 1,400 feet per second
But will we have the stability? Here we go. Go! Okay, that one looked pretty good.
Now, we did not get a speed reading on this one, but it should have been going at least 1400 to 1450 feet per second. And it was pretty darn accurate. Now, it looks like it was flying pretty stable. Should have been spinning close to 30,000 RPM, but it looks like it started to yaw a little bit near the end there. But it did hit exactly where I was aiming, so that's always a good thing. And we didn't hit the steel frame this time.
That wasn't too bad. I was aiming in the center, just a little bit low, but it looked like, it's hard to tell on the screen, but it looked like it was flying stable. Not seeing any fragments of wood or anything like that yet. Wait. Here's a wood fragment, so yeah, and it does look like it didn't, it didn't keyhole or anything when it entered it might have started tumbling once inside there, but we had, of course, this is the back side, full exit, lots of damage, so I'm pretty happy with that one. Finally got some kind of decent result with these things. Maybe 30 grains is the magic number here. I'm not sure. That last one seemed to do well, and I think we should get a redemption shot on the lead plate, because I would like, these things have a very good chance of penetrating that lead plate. So if we don't do that, I think we'd all regret it. So let's see how 30 grains does on that. All right, here we go. Okay, I think that was a little better shot. I don't think I got another rating, but these should be, again, about 1400 feet per second. All right, here we go.
Now, in this shot, we had something that I call spin out occur. It's when you're accelerating the projectile down the barrel. It's going from 0 RPM to 30,000 RPM. Well, that heavy core really resists wanting to move just from inertia. So it's like a super impact wrench trying to spin that thing to that super high RPM, and the core just spins right out of the body. Now, we've seen this happen before, usually with heavy tungsten cores. It's very difficult to keep that from occurring, no matter how much Loctite or epoxy or wood glue or whatever you use. It's a very strong force. But I kind of anticipated this could happen. That's why I used the graduated powder loads. There's a huge difference in inertial torque, if that is the proper term or not. I'm not sure. I call it spin out, between 20,000 RPM and 30,000 RPM. But this is a really important lesson for future designers when they come up with their own slug designs.
Well, it was hit about where I wanted it to, but again, obviously keyhole, just a gnarly gash there, as big as my finger. That's pretty big there, right? I mean, I've been finding the sabos. I always pick those up, and it looks like we've got good engagement with the rifling. You can see the rifling on there. Okay, we got one 30 grain left, and we're gonna shoot at the ballistic bucket of wet sand. Last one, let's see if it works. Hit it! Nope. 1330 on that one. So a little, I was estimating, maybe about 1400, but only 1330 on the lab radar. Hit it! Nope.
And the very last one is totally unstable and once again hits our steel frame. Now, we haven't discounted the possibility
the scientific possibility that these might be haunted. They are made out of antique organ parts, so this might be haunted and are tormenting me by hitting my steel frame over and over again. But in all seriousness, I think the biggest problem or challenge here is the fact that they are so dang long, and that most of the mass is in a skinny little core running down the center of it. And typically the longer and skinnier the projectile is, the more difficult it is to stabilize, and you have to get a lot more RPMs to stabilize something like that. But if you try to spin it too hard and too fast, well, you get the spin out. So it's a fine line between success and failure. The bucket of sand lives another day. It's 3 gallons of wet sand. FBI calibrated wet sand, right? These things seem to like hitting our bracket there. It's better, I guess it's better that it hits that than the table and does more damage to the table. But the table did pretty good today, didn't it? I did a little hammered work on it, knocked it back into shape so it wouldn't, you know, collapse on itself. It's a good little table. It's just, and it's a tiny little table, so it works good for my tiny little truck. So anyway, that's it. Terrible result. I should have stayed home today, but horrible high-speed camera footage. Definitely is too dark for filming high speed. That was as slow as I could run the camera. Normally I run at about 10,000 frames a second. I'm running at 1,500. That's, you know, I don't care how many lights you put out here, it's not as bright as the sun. It really isn't. I mean, unless it was like a searchlight, you could light it up with a searchlight and it might be bright enough. But I see something on the ground over here. And we have one of the cores. So it is, I had no idea the core actually went all the way through it, believe it or not. I know there was something coming out of the back, coming out of the front, but I wasn't 100% sure it was one core. So that's, I don't know, it's about a 3/8 of an inch there, or about 10 millimeters or so. And you can see that was the tip, of course. So that one, whatever it hit, it could have been that angle iron thing there. Did a lot of, you know, you can see heat, you know, heat coloring there. But oh my gosh, is that another one? Yeah. Okay. And there's another one. What's good is I could throw this in the bag of all the other slugs someday we'll send back to Evan. I've got them, you know, look at how much that opened up. Whatever that hit, we don't know what these hit. That really mushroomed out. So that's it. I am ready to go home. I'm freezing my butt off. It must be 45 degrees out here, which is cold for us. So anyway, I'm sorry, folks. I hope you still enjoyed it. Some people like watching, you know, the failures, but they're probably the same kind of people who like getting food poisoning. But anyway, thanks for watching. We got possibly Officer Grave coming into town in the next couple of weeks, so look forward to that. We'll see you next time.